The etymon of atom is a, meaning not, or a takeaway, and tumos, and which kind of is reminiscent of tutmos, and just kind of popped in my head. But anyway, tutmos, a cutting, to cut. Tim. All right, real quick, let's go to the Egyptian hieroglyphics dictionary. Now remember, atom came from atim, just which a tin mean to cut, right? Tim mean to cut, right? Look at that. In hieroglyphics, Tim means to cut. Atim. Get it? Peace, peace, peace. What it do? All right, man. This video, this part of this video, this series is kind of difficult because, man, I really can't believe that intelligent people believe this stuff. It really amazes me how simple this stuff maybe can be, but it really seems to be the powers that be are making it more difficult than it has to. And I believe I know why. And like I said at the beginning of these videos, all is just my perspective. You know what I mean? Just don't make sense to me, the things that they say. And I'm gonna show you. And I would love to hear your rebuttals. Like, seriously. Like, you know, I don't say this often, but just share this video. Like, I want people to answer these questions, because this shit makes no sense. Like, this is ridiculous. Okay, so let's go. The history of the atom. So when you say atom, this is what we talking about before we go on to the future science. Remember I told you last we left off with the structure of the atom, because we're going to present a new structure of the atom. Well, I'm going to present to you what is presented in this book, Future Science, which I suggest you go get now. And also holler at the author. Look it up. Try to get it from the author. He has his own website. I believe it's still a reasonable price on his website. If you go to Amazon, you know what I'm saying, you're gonna spend some coin. Not Bitcoin either, goddamn. You might get it for $200 from somewhere. Shit, be real though. If you gonna spend $200, I would rather give you my copy. $200, crying a bit. Anyway, I think the author got it for he got it for 50 or something. Anyway, I'm prolonging, man, because I really can't believe this. Okay, so let's look at the atom. We're gonna look at the history of the atom. All right. So Dalton drew upon the ancient Greek idea. Stop right there. So where did the atom come from? The ancient Greek idea. The word atom comes from the Greek atomos, meaning indivisible. His theory stated that atoms are indivisible. Those of a given element are identical, and compounds are combinations of different types of atoms. The plus is it recognized atoms of a particular element differ from other elements. The negative is atoms aren't indivisible. They're composed of subatomic particles. Okay, so let's stop right there and let's look at the etymon of atom. Okay, atom, like a bit etymon. The etymon of atom is a, meaning not, or a takeaway, and tumos, and which kind of is reminiscent of tutmos, and just kind of popped in my head. But anyway, tutmos, a cutting, to cut. Tim. All right, real quick, let's go to the Egyptian hieroglyphics dictionary. Now remember, atom came from atim, just which a tin mean to cut, right? Tim mean to cut, right? Look at that. In hieroglyphics, Atom means to cut. Atom. Get it? Okay, to cut. An ancient term of philosophical speculation in Lydipus and Democritus. Okay, keep these two in mind. We're going to go into these two in a second. Revived scientifically in 1805 by Dalton. Okay, remember Dalton, 1803. Okay, Dalton. All right, so let's look at this person and this person. Okay, now it's credited mostly to this person. Okay, I'm gonna show you that here. If you go to the, we're going to the Shipley's Origins of Words. All right, and you see Atom goes back to L, Ne, and Tim. L is element. Ne is the A, the negation, the takeaway. And Tim is what they told you. Tim means to cut. Okay, so the atom means a negative, that which cannot be cut. And it says, now we know better, right? All right, peep all this. As early 5th in BC, the idea from that, like they told you, I don't know how to pronounce it, spread by the Latin philosopher who is Democritus. All right, that's the laughing philosopher, Democritus. All right, so let's go to this dude, because I'm proving to you that the idea of an atom being the fundamental building block of reality is an ancient idea. And what I say in the last video is they have to make up this quantum shit so they don't admit that the ancient ways were right. I couldn't think of a rhyming word. No, so they don't want to admit that the ancient people knew what they was talking about, and that today's modern science is a bastardized version of the ancient teachings, okay, which describe in today's modern science also describes observations, and yesteryear's science explains and offers an understanding of phenomenon, as opposed to just describing it with mathematical equations. So, the Greek tradition regarded Lydipus as the father of atomism in ancient Greek philosophy. Little is known about him. His views are hard to distinguish from those of his associate, Democritus. See, I told you, spread by Democritus. Check this out, though. This is what's important. The extent of your boy's contribution to the development of the autonomous theory is unknown. His relationship to Democritus, even his very existence, was subject to considerable controversy in the 19th century. Graham. Okay, so essentially, this person probably never existed. Once again, the Greek society that these people claim to have inspired, these pale-skinned Europeans, it's just not real. It never existed. The Greek society that they prompt up is the Etruscan society. Most of the statues that they put up are fake. I've shown that in videos. So the whole claim, that's why they always try to divert any ancient high society to Greek, and never really try to mention Egypt, because Egypt is proven to be dark-skinned people, and they have this facade of Greek being an early high civilization of Europeans, and it's just or what I should say, modern day pale-skinned Europeans, and it's just not real. This is why if you look at any of their high scholars, there's always a question of their existence. Half of it is not proven. Okay, like Plato, Socrates. Just look into it. And this is not the point of this video, to go prove and all that, because I don't need to. I can go to this book right here. Okay, Stolen Legacy, right, by George G.M. James. Shout out to the elder, because this book is old. And he gonna tell you Greek philosophy is stolen Egyptian philosophy. Before I read this, let me go to this video. Old video I did about 3 years ago. And just to prove this point to you, it's funny, after I go from this book, I go to the book that I'm actually focused on in this series of videos. So I'm gonna let that play too, so you get that lesson, because that's gonna come into play later. So peep. It's only just one. Alright, what they never told you in history. in history class, volume 1, in this Indus Kush. Kush is more as well. What I'm marking here, I don't even know. It's a while ago. Look at that, Greece and Rome founded everything from Egypt. All right, that's what that was about. It's childish. It's childish to assume science began in Greece. See, they got everything from us, people. Everything. All right. The origin of Greek philosophy. The Black Egyptians were the first teachers of ancient Greeks. All right. So, get into that. All right. So, you see, Greek philosophy came out of Egypt. All right. And I'm going to get a bit more specific when I go back to Stolen Legacy. But I just want to show you this part of the rest of this video, well, a piece of this video, when I go into future science and how this, and it'll relate to the lesson later on. So, peep. This one ain't one that people talk about, but this is good, great information for your mind. It shows how the atom really functions. It's very important. It will make a lot of cosmology jump out at you. And then in this book, in the back, the reason why I recommend it, because hold on, I think I got it marked. In the Science of the God, right? Science of God, chapter 4, first place he goes is the mystery of the Maya. All right. Now we know the Maya is the Olmecs, and he knows that the Olmec head, right? This nigga, this Naga with this black nose and yada yada yada, is an earlier incarnation of Quasi-Koto. See what I'm saying? So we talking, goddamn me, they God of that land. Who look at her, who died on the cross. This was before your Jesus story, family. All right, we already had that motif over here in Quasi-Koto. All right. All right, so you see that the Olmec head, which is a depiction of a so-called African or a dark-skinned person, was Quasi-Koto, which was the crucified savior of the Mayan people. Okay, so you see that motif of a crucified savior dying on the cross predates Cortez or Columbus bringing Christianity to Central America, and he was a dark-skinned person. Now, understand. So just so you'll get the understanding that it all goes back to dark-skinned people, just like Greek philosophy goes back to Egypt. And if you look into it, you'll see the connections between the Olmec civilization and the Egyptian civilization. So understand that Maya, right, means illusion, and I'll let him explain here in this video as I'm reading in that video. The word Maya, an ancient Sanskrit word meaning illusion. Why would the people name themselves illusion? Don't even make sense. You're living in Maya. Okay? The world is Maya. Okay, so you heard him, what Maya is, an illusion, right? So let's get a little bit more technical. It's a term applied by the Hindus in a philosophical or mystical sense to that power which caused or created the visible phenomenon of the universe. You understand what I'm hinting at here? That the word Maya essentially means the atom. Okay? The illusion that the atom creates. And you see when it says, it assumes that external objects have no absolute existence, but they are mere impressions on the mind. And this is because the ancient people knew that the world was made of atoms. And look what it tells you to see. More. Because what did I tell you? This is Moorish science. Okay, so we'll continue on. Let's go back to Stolen Legacy. Okay, so you see I showed in that book, but I don't have that book no more. I let somebody borrow it. I don't even remember where it is. I don't even remember who it was, but anyway. So this tell you, Greek philosophy is stolen Egyptian philosophy. The teachings of the Egyptian mysteries reached other lands many centuries before it reached Athens. According to histories, Pythagoras offered, after receiving his training in Egypt, okay, that's where they whole mathematical for the triangle and the whole number system that they claim is all from this guy. And here you go. From Egypt, returned to his native land, Samos, where he established his order for a short time. You see, long story short, in like manner, we are informed that that Greek person, that Greek person, that Greek person, and look at your boy, Democritus, were also natives of Iona who were interested in physics. Hence, it's tracing the course of so-called Greek philosophy. We find that Ionian students, after obtaining their education from Egyptian priests, returned to their native lands, while some of them migrated to different parts of Italy, where they established themselves. And he established atomism, however you pronounce it, which is where modern people get the atom. And we see that came from Egypt. And we also know that Egypt was Timeri, land of the Moors. Okay, and we know that the high priest of Timeri was the Moors. So when we talk in atomism in the science of the atom, who are we talking about? Moorish science. Here we go again. So let me go back to this here. Now, they'll tell you that subatomic particles are what make up the atom. But remember, that's where you get quarks. Remember the mathematical problems that equal these things, and the glue, the dark energy and the dark matter. Remember all of that? That's why I told you all of that, because all of that is how they describe these subatomic particles. Hence, quantum physics. You get it? Alright, so let's keep going. Thomas discovered the electron, which he called corpuscles, in atoms in 1897, for which he won the Nobel Prize. He subsequently produced the plum pudding model of an atom. It shows the atom as composed of electrons scattered throughout the spherical cloud of positive charge, which is kind of interesting when we get here. Okay, recognize electrons. Okay, but no nucleus. He didn't explain the nucleus. All right. So then your boy Rutherford, and that's where we gonna pick up at in the future science book with Rutherford. But I'm just gonna show you here, and then we'll go to the future science. But check it. Rutherford fired positive charged alpha particles at thin sheets of gold foil. Most passed through with little deflection, but some deflected at large angles. This was only possible if the atom was mostly empty space with a positive charge centered in the center, the nucleus. Realized positive charge was located in the nucleus of the atom. Didn't explain why electrons remain in orbit around the nucleus. They don't understand why electrons orbit the nucleus, because if this is a negative charge, this is a positive charge, they should collapse. Opposites attract. Remember, the guy said that in the strong force video. Remember? Okay, so Niels Bohr modified Rutherford's model of the atom by stating that the electron moved around the nucleus in orbits and fixed sizes and energies. Electron energy in this model was quantized. Electrons could not occupy values of energy between the fixed energy levels. Proposed stable electron orbits explain the emission of a spectre. The emission spectre of some elements. The emission spectre is the electromagnetic energy that comes off of it. That's what they're talking about there. Okay, but moving electrons should emit energy and collapse into the nucleus, so the model doesn't work, right? So peep this. This is where this shit gets hilarious. That's right there. Okay, so none of their models make sense to them. Okay, you see, they don't understand how it works. That's when they created this strong force that makes up of this glue to to describe this stuff that doesn't make sense to them, right? So where do they go to next? Schrodinger's cat. Okay. Dude, I imagine y'all may be familiar with Schrodinger's cat, but okay, watch this video.
So without further ado, we present Schrodinger's cat. I'm sure you've heard some version of this famous thought experiment. You put a cat in a bunker with some unstable gunpowder that has a 50% chance of blowing up in the next minute, and a 50% chance of doing nothing. The gunpowder is Einstein's version. Schrodinger preferred poisonous gas. But whatever. So until we look in the bunker, we don't know whether the cat is dead or alive. And when we do look, it is either dead or alive. So if we repeat the experiment enough times with enough cats and bunkers and gunpowder, we'll see that half the time, Kitty survives, and half the time, Kitty goes bye-bye. The quantum mechanical interpretation is that before we look, the cat is in a superposition. It's both dead and alive. And our act of looking forces nature's decision. So our curiosity kills the cat. But what about the cat's perspective? Well, the cat either sees the gunpowder explode or not. So inside the bunker, we actually have these two possibilities. The powder explodes and the cat sees it explode, or the powder doesn't explode and the cat doesn't see it explode. There's no option, the powder explodes and the cat doesn't see it explode. So the cat's reality becomes entangled with the outcome of the experiment, and it's our observation of the experiment that forces nature to collapse to one option or the other. But we're like the cat too. Either the cat dies and we see it dead, or the cat lives and we see it alive. So who's observing us to force nature to collapse to one reality? Or do both possibilities happen in parallel within a larger multiverse? This collapsing to one reality problem is one of the biggest unanswered questions in quantum physics. So for kitty's sake.
Okay, so you see, Schrodinger's cat. Oh my God. So, you understand? The cat is the electron. Okay? You remember the questions. See, that's why y'all watch the whole. I hope you watching this whole series because I'm not going back. The questions of physics was, is it a particle? Is it a wave? Right? Remember? That's Schrodinger's cat. Is the cat dead or is it alive? Right? So, because they can't figure out how this works, they just say it's both. And when you go to the fundamental understanding of the atom, which is the fundamental element or particle that makes up our reality, they take you to a thought exercise. They take you to a thought experiment that illustrates an apparent paradox of quantum superposition. Do you understand? So essentially, when it comes to the fundamental particle of our reality, the question is is the cat alive or dead? Okay, this is hilarious to me. These people know nothing. I mean, they've been, whatever. That's what they believe. I mean, this is your physics. These are your quantum physics. The cat is in a box and it's gonna die. So at any moment, it could be alive or dead. This is how they explain the atom. Wow. Or it's the glue and the dark energy. Oh, anyway. Okay. So this is where they are, man. You see, that's where it take you when you go to the history of atom. It don't go no further than this. This is where they at. Other than some magical glue that they haven't figured out works or even know if it exists. So, once again, I told you I'm going to offer you a different perspective, and you do what you wish with it. You understand what I'm saying? So we're going to go into a new look at matter in the Future Science book, and we're going to explain some things. So let's go. A new look at matter. In 1920s, when the Nobel Prize-winning physicist Ernest Rutherford set down his theory on atomic structure, it all seemed quite straightforward. The smallest body of matter, the atom, was comprised of positive charges in the center, the nucleus, which he called protons, and negative charges that orbited the nucleus, electrons. Different fundamental materials elements were distinguished by the number of protons and electrons. For example, calcium was found to have 20 protons and 20 orbiting electrons. Rutherford chose a billiard ball style convention to illustrate the protons, figures 7a and c, and the negative sign to illustrate the orbiting electrons. But later experiments showed the weight of the nucleus to be twice as heavy as he had initially proposed, which meant there had to be yet another undiscovered particle, the one that had no electric charge inside the nucleus. By 1932, the British chemist James Chadwick had identified the missing particles and named it the neutron because it appeared to have no electrical charge. Rutherford then redesigned his atoms to include the missing neutrons, figure 7d. He found no problem in accommodating the electrically electrically neutron into his existing model by simply illustrating his new complete atom, showing the neutrons like small billiard balls of different color inside the nucleus. This billiard ball perception of the neutron would in time be seen as the greatest scientific misconception of the 20th century, which together with Newton's ill-conceived definition would deny the discovery of gravity for generations to come. But Rutherford's model, accepted by science today, contains even more disturbing features. It fails to explain, figure 7a, why the positive proton does not simply spring apart, their positive charges repelling each other, or why the negative electrons do not get sucked into the positive nucleus, thus annihilating the atom. Alright, so figure 7c. So just like he said in the beginning, they don't know how the electron isn't sucked into the proton and annihilates the atom in itself, because negative attracts positive, right? So he was quoting figure 7 just so you can see the construction of the theoretical atom by Rutherford. They just put in a neutron. They put these put a negative, positive, and a neutral particle inside of a neutron. Smash that next to the proton. They said this how the atom works some kind of way, but they don't understand how. Just like they told you on here. Rutherford doesn't explain why electrons remain in orbit. Okay, so let's keep going. Construction of the neutron, the most undervalued discovery in the history of science. From 1932 to 1959, virtually nothing new was learned about the composition or construction of the atom. Then, in 1960, experiments using new atomic particle acceleration smashed together two neutrons as though they were boiled eggs. Following the forced collision, they were amazed to finish up with two positive particles, two negative particles, and two particles that appeared to do nothing, which they named the antineutron. This meant that each neutron must consist of three particles, one positive, one negative, and one neutral antineutrino. Figure 7e. But they argued it did not really matter anyway, because positive cancels out negative, and therefore the neutron is still overall electrically neutral. So they simply filled in Rutherford's neutral billiard ball with one positive charge and one negative charge and one neutral neutrino, and in so doing missed the chance to redefine the atom. Worse still, this model, accepted by physics today, still raises yet another alarming question. If the neutron does contain a positive charge and a negative charge as shown in figure 7e, then why do they not get sucked together and annihilate each other? This conventional explanation of the atom raises far more questions than it answers. We have conjectured that gravity waves bombard matter in an attempt to explain how gravity might work on, implicitly recognizing that the waves could only ever explain one half of the interactive mechanism that might exist between waves and matter. Now we can see why modern science has failed to find or explain any interactive mechanism, because they do not understand any of the available information. Orthodox physicists do not understand why the protons in the center of the atom do not spring apart, or why the orbiting negative electrons do not get stuck into the protons, or why the positive charge inside the neutron is not sucked into the negative charge inside the neutron. They have tried to reconcile energy with matter like a blind man groping in the dark, without firstly understanding the nature of energy, the necessary corkscrew style characteristics of electromagnetic energy, or the nature of matter. It could hardly have been worse. It beggars belief. Surely someone somewhere along the way over the past 80 years must have realized that something was seriously wrong with their atom. Incredulously, the answer is no. You see why I said at the beginning that this video was difficult to do, because it's amazing the flaws within the model that these people, like very intelligent, highly intellectual people, are speaking about, and it's flawed on its face. And you know, all they can come up with is some thought exercise about a cat in a box. You see? So we're gonna finish off with this point, and then we're gonna go to the next one. So peace. If we could construct a model of the atom that answers all of the crucial questions, then any rational inquirer would have to agree that it must be a better model than the one we have today, and moreover, that it would be more helpful when trying to figure out how energy might interact with an atom in such a scheme. Continuing with our example of the calcium atom figure,